I'm Einat Lev. I'm a Lamont Assistant Research Professor. I study volcanology at the Lamont-Doherty Earth Observatory at Columbia University. What inspired me to study volcanoes is I've always been interested in combining physics and nature, and also interested in helping society in predicting hazards and preventing disasters. During my PhD, my work was very theoretical and looked at mantle convection and plate tectonics. So when I graduated, I decided to switch gears to work on something that was more applied, something that I actually can go and visit and see the more direct daily impact on people's lives. And that led me to volcanoes. Some very exciting fieldwork that we've been doing in the past year or so took us to quite a few different places. One was Iceland, where we visited pretty much the largest lava flow to have happened in centuries anywhere in the world. And we looked at how that lava flow interacted with its environment. It actually flowed over a river and made that river stop and find another path. Then we went to Chile, where we looked at an interesting volcano named Kizapu that within a few decades had both a very big effusive lava flow producing eruption and then a huge explosive eruption that covered the whole thing. So we wanted to look at the structures and try to decipher what was going on with that volcano. We used, in both places, we used both samples that we collected and also a drone that took a lot of videos and photos from the air that we then used to construct a model of the lava flow structure. And the biggest advantage of using drones is that they can take you places that they're very difficult to get to. We couldn't map the structure of the lava flows in Iceland in the interior part of it because it was just too difficult to reach. And the drone just flies above and gets us that data. Same in Chile. Those flows were 100, 200 meters tall and very difficult to climb on. And the drone just flies over and collects that footage for us. One thing that is important for the public to appreciate is that a lot of the models that scientists use to predict when a volcano is erupting or how far a lava flow would go or where would it go use pretty simple physics. And there's a lot that we appreciate that the physics of magma and lava should be more complicated, but we don't exactly know how to put it into those models. So that's what we're trying to provide here, some of that physical understanding of how to make hazard assessment and predictions better.